This ASRJC question looks simple, but I promise you it's actually really tricky. Let's take a look at this question over here. So this is a PNC question, which is a permutation and combination question. And feel free to pause this video right now to read the question before we actually attempt it. So in the context of the question, we have 4 musical notes followed by 3 beats. So we have note, 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 followed by beat, 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 beat. And each note over here, there are 7 possible different notes. And in each beat over here, there are 5 different possible beats. So the question is asking us, what's the probability that a randomly chosen sequence has exactly 2 notes the same or exactly 2 beats the same but not both. And the tricky part about this question is actually the but not both portion, which you need to address inside your working. So in this case over here, let's first calculate what are the total number of different combinations. So the total number of combinations without any restriction, that would be 7 to the power of 4 times 5 to the power of 3 essentially. And the reason is as such is simply because if there's no restriction, each note can have 7 different variations. So 7 times 7 times 7 times 7, which is 7 to the power of 4. And each beat will have 5 different variations. There's no restriction. So 5 times 5 times 5 gives me 5 to the power of 3. So that's fairly straightforward. And this is something that we can just compute into our calculator first. So 7 to the power of 4 times 5 to the power of 3, that will give us 300125. But now we need to answer the question and find out the probability of 2 notes exactly the same, 2 beats exactly the same, but not both. So scenario 1 is 2 beats exactly the same. And don't forget, we need to follow what the question wants, but not both. So at the same time, we also have to fulfill another condition, which is and the first one is 2 notes exactly the same. So 2 notes exactly the same and no 2 beats the same. We need to fulfill these 2 conditions over here. So how do we fulfill this first condition over here, whereby 2 notes are exactly the same? You see over here, I have 4 different slots, and out of the 4 different slots, I need to choose 2 first. So 4, choose 2. Now I've chosen the 2 slots. How many pairs can I fit in there? Well, there are 7 possible different notes. Therefore, I can fit 7 different pairs inside these 4 positions. And therefore, once I pick these 2 positions already, the remaining 2 positions will be the ones that are different. So that would mean times 6 and times 5. Now at this point over here, don't make this mistake of multiplying 6 2 times. You need to multiply 6 followed by multiply 5, because the last pick that you take cannot be the same as the pick that you take previously. If not, there might be a case where there is more than 1 pair that is exactly the same, right? So we need to decrease one more time to 5. Now, how about this condition over here, whereby no 2 beats are exactly the same? So if no 2 beats are exactly the same, we can also think of it as such, right? Which is every single possible combination, so 5 to the power of 3, minus the number where the 2 beats are the same. We take the complement of it. So 5 to the power of 3 minus how many combinations are there where 2 beats are exactly the same? That is where you take 3 choose 2, multiply by, then after that you got 5 different possible pairs, so times 5, right? And then the last pair would be a value of 4. So when you key this into your calculator, you get 3 choose 2 times 5 times 4, and you get a value of 65 over here. So for the first total condition, you just need to multiply everything together, inclusive of the 65. So 4 choose 2 times 7 times 6 times 5 times 65, and you'll get 81900. Now for the second case over here is the opposite. We have 2 beats the same and no 2 notes the same. So how do we calculate this? For 2 beats exactly the same, you realize that it's actually this value over here that we calculated earlier on, which we minus away, right? So it's just from here, 3 choose 2, right? 3 slots I choose 2. Once I choose the 2 slots, I have 5 different pairs that I can slot in there, and then I multiply by 4 for the last slot. And over here, no 2 notes exactly the same will be to just take 7 to the power of 4, which is all different possible combinations. I minus away the ones where 2 notes are the same, right? And that will mean 7 to the power of 4 minus 4 choose 2 times 7 times 6 times 5, which gives me a value of 1141. So when we actually combine these two and multiply everything together, we get a value of 68460. So therefore, to answer this question over here, the required probability would be 81900, which is case 1, plus case 2, divided by the total possible combinations, which is 300125. And eventually I get a final value of 0.50099 which is 0.5012 as you can see over here. So this is the final solution to this question over here. And what I found is that actually for J2 topics, it requires a lot more practice because the questions are just so much more unorthodox, not so standard anymore, and there can be really many scenarios. So if you like to get an access to a library of more of such questions like this and really increase your breadth and depth in your revision in terms of how many questions you have on hand and also the scope of the questions, the amount of question types for each chapter, at my Math Tuition Center, I created a library called the Library of A1 Math Academy that gives you exactly that. that. And not only will you be getting access to this library of all of these videos, resources, and questions, but you also get access to our 24-hour turnaround marking service where we'll mark your work that you send to us within 24 working hours. For more information, make sure to WhatsApp this number over here, and I'll send you a demo link to our website to actually see how this whole library actually works. And I'll see you on WhatsApp.